In 1873, James Clerk Maxwell published an article titled On Action at a Distance. In this article, he compares and contrasts the different perspectives on how forces are transmitted between two objects. And in the last couple of lectures, we've been looking at these two perspectives. Remember, the first perspective is that of mediated action. That is, for something to push on something else, they must in some way be connected, or there must be some medium that mediates the action between them. The other perspective is on action at a distance, or direct action at a distance, and this is the perspective that one object can push on another object without any kind of medium connecting them. So we've been looking at chapter 30 in A Student's Guide to the Great Physics Text, volume 3, and in the last couple of lectures we've gone through several arguments for each of those perspectives, and that brought us to about the bottom of page 383. So here we pick up our reading. If the progress of science was regulated by Newton's first law of motion, it would be easy to cultivate opinions in advance of the age. We should only have to compare the science of today with that of 50 years ago, and by producing in the geometrical sense the line of progress, we should obtain the science of 50 years hence. So he's saying, if science obeyed certain laws of progress, then it'd be easy to predict what was going to be discovered 50 years from now. Of course, he's being a bit tongue-in-cheek because he's noticing that you can't predict what's going to happen in science 50 years from now because science itself does not obey Newton's laws of motion. He says the progress of science in Newton's time consisted in getting rid of the celestial machinery with which generations of astronomers had encumbered the heavens, and thus sweeping cobwebs off the sky. So he's talking about the work of Isaac Newton was a revolutionary work in that he came up with a universal law of gravity that was able to explain the motion of the planets around the sun and the Earth's moon around the Earth. And before that, the idea was that the heavenly objects like the planets were orbiting around either the Earth or the sun because of celestial spheres or enormous kind of crystalline spheres on which they were riding, and that's what gave rise to their motion. So he's talking about kind of in the history of science, Newton's work was said to sweep the cobwebs off of the sky. That is to provide another kind of invisible force explanation for why the planets were moving around the sun, instead of the previous mechanical perspective of why the planets went around the sun. Though the planets had already got rid of their crystal spheres, they were still swimming in the vortices of Descartes. Magnets were surrounded by effluvia and electrified bodies by atmospheres, the properties of which resembled in no respect those of ordinary effluvia and atmospheres. So here what's Maxwell doing? He's talking about some of the alternative theories to Newton's theory of gravity that were contemporary with Newton. So Descartes had the idea that the planets were going around the sun not because they were encased in these crystalline rotating spheres, but rather there was some fluid that filled all of space, and this fluid was spinning around in kind of a whirlpool around the sun, and the planets were going around the sun kind of like a rubber duck would be going around your bathroom drain as the tub is draining because they're being swept along by the rotating fluid. That's Descartes' idea, this vortices swirling around the sun that were carrying the planets around. So he's saying this idea was popular around the time of Newton. And he goes on to say, when Newton demonstrated that the force which acts on each of the heavenly bodies depends on its relative position with respect to the other bodies, the new theory met with violent opposition from the advanced philosophers of the day, who described the doctrine of gravitation as a return to the exploded method of explaining everything by occult causes, attractive virtues, and the like. So it's easy now to say, well, Newton had a very scientific theory, the universal theory of gravity, but at the time it met very violent opposition. Why? Well, think about it. Newton was claiming that the sun is pulling on the Earth, and nothing was connecting them. No strings, no ropes, no nothing. And that's about as close to magic as you could probably imagine. There's an invisible force pulling one thing toward another. And so the opponents of Newton accused him of introducing the occult or the hidden back into science that we thought we had gotten rid of with the ideas of swirling vortices going around the sun. Newton himself with that wise moderation which is characteristic of all his speculations, answered that he made no pretense of explaining the mechanism by which the heavenly bodies act on each other. To determine the mode in which their mutual action depends on the relative position was a great step in science, and this step Newton asserted that he had made. To explain the process by which this action is effected was a quite distinct step, and this step Newton, in his Principia, does not attempt to make. So in other words, Newton's law of gravity was able to explain, or rather was able to describe the force of attraction between the sun and the earth, or between the earth and the moon, using a mathematical equation, but it didn't really explain why this force was acting. It didn't give a mechanism. And so it was a mathematical description, but not a causal explanation, you might say. But so far was Newton from asserting that bodies really do act on one another at a distance, independently of anything between them, that in a letter to Bentley, which has been quoted by Faraday in this place, he says, and now Maxwell is going to read a letter that Newton wrote to Bentley, where he's claiming that he doesn't know why the sun is pulling on the earth. He knows how it is, using the universal law of gravitation in its mathematical form. And although he doesn't know why, he's pretty sure that there is some kind of mediated action. There is some kind of connection between the earth and the sun, even if he doesn't know what it is yet. Newton says, "It is inconceivable that inanimate brute matter should, without the mediation of something else which is not material, operate upon and affect other matter without mutual contact, as it must do if gravitation, in the sense of Epicurus, be essential and inherent in it. That gravity should be innate, inherent, and essential to matter, so that one body can act upon another at a distance through a vacuum without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it." So he's not mincing words there. He's saying here that even though he doesn't know what the medium is that communicates the gravitational force, he thinks there has to be one, and that's kind of the basis of philosophy, and if you don't believe that, you're not really a competent philosopher. Accordingly, Maxwell goes on to say, we find in his optical queries, Newton's optical queries, you've read some of his optics this past semester, in his optical queries and in his letter to Boyle, that Newton had very early made the attempt to account for gravitation by the means of a pressure of a medium, and that the reason he did not publish these investigations proceeded from hence only that he found he was not able, from experiment and observation, to give a satisfactory account of this medium and the manner of its operation in producing the chief phenomena of nature. So Newton tried to come up with a material explanation using some medium, but he wasn't satisfied with his explanation, so he didn't push it. Maxwell goes on to say, the doctrine of direct action at a distance cannot claim for its author the discovery of universal gravitation. It was first asserted by Roger Coates in his preface to the Principia, which he edited during Newton's lifetime. So what Maxwell is going to explain now is how, although Newton was not an advocate of action at a distance, Newton believed in mediated action, those who published Newton's works and advocated for Newton's Principia took the opposite perspective as Newton himself. Roger Coates, notably, is going to push the idea that gravity is an example of an action at a distance. He says, Roger Coates, in his preface to the Principia, which he edited during Newton's lifetime, according to Coates, it is by experience that we learn that all bodies gravitate. We do not learn in any other way that they are extended, movable, or solid. Gravitation, therefore, has as much right to be considered an essential property of matter as extension, mobility, or impenetrability. So, in other words, Coates is arguing that it is by observation that we learn objects have size. It is by observation that we learn that objects are solid. It is by observation we learn that objects are able to move, and it is by observation that we learn objects have gravity. And all of these things are, according to Coates, essential or inherent in matter. And when the Newtonian philosophy gained ground in Europe, it was the opinion of Cotes rather than that of Newton that became most prevalent, till at last Boskovic propounded his theory that matter is a congerie of mathematical points, each endowed with the power of attracting or repelling the others according to fixed laws. In his world, that is in Boskovic's opinion, in his world matter is unextended and contact is impossible. He did not forget, however, to endow his mathematical points with inertia or mass. In this, some of the modern representatives of his school have thought that he had not quite got so far as the strict modern view of matter as being but an expression of four modes or manifestations of force. So the popularizers of Newton, people like Cotes and Boskovic, were advocates of immediate action at a distance, although Newton himself was an advocate of mediated action. Father Boskovic actually has an interesting case. He believes that all of matter is comprised of infinitesimal points, and these points exert forces on other points, but they never, in fact, touch one another, and they're, in fact, points of zero size, so they're mathematical points rather than physical points. So it's a very abstract view of matter. So if you're thinking that that the difficulty in understanding nature is perhaps understanding the mind or the soul, from this perspective, or even from a modern perspective, you might say that really the most difficult thing is understanding what matter really is. And with the advent, I might say, of quantum theory in the 20th century, this abstraction continues to plague science, in that matter, what the nature of matter is, really continues to be increasingly a puzzle.